Maths 1A. Maths 1A, chapter Mathematical Induction. Today we are going to solve important repeated problems in this video. Okay, come let us join children, join this live session for maths important questions. Okay, come on children, this is live session for important problems on the topic mathematical induction. Welcome to my maths notebook channel. Here I have written some problems for you, very important repeated problems for board exams. So I think you have started this chapter. Welcome to live session maths mathematical induction. Okay, I am going to show the solution for you. Easy steps how to solve this type of questions. Many children have doubts and how to use this, how to solve this problem in exam within minutes. Okay, if you understand the mathematical induction step by step, you can solve many problem based on this topic, mathematical induction topic. Important and repeated problems. I have uploaded functions topic also. Maths 1A students who are intermediate 1A. This is part 1 for mathematical induction chapter. Okay. If you have any doubts in any topic, go through my channel for more videos. Okay. Let us start now children. Use mathematical induction. What it is given here. Use mathematical induction to prove the statement 1 cube plus 2 cube plus 3 cube plus so on. Here n cube is given up to n cube. Okay, this is n cube is equal to n square plus n plus 1 whole square by 4 for every n belongs to n natural numbers. Okay children, so let us solve this problem children. Whenever this type of questions are given, don't worry, very easy steps we have to take. Okay, first we have to prove. Let us take now p of n. We have to take be the statement, given statement we have to take as p of n. Okay, now p of n is what? This statement, the whole statement we are taking as p of n is equal to what? 1 cube, 2 cube. Let us assume this as p of n plus n cube is equal to n square n plus 1 whole square as given in the question for every n belongs to capital N. Okay, now what we have to do children? Nothing that for n is equal to 1 we have to solve. Okay, next we have to take n is equal to k, and next we have to show that n equal to k plus 1 also true. Okay, I will show step by step. Since let us take n equal to 1. Okay, in first step we have to prove that n equal to 1 is true for this statement. Okay, since we have to put p of 1 is equal to 1 cube plus 2 cube so on. That is we don't want to write this one, all this one we have to write. N cube is there, no? So 1 cube. 1 cube means 1. And here in right side what? Put in place of n we have to keep 1. Okay. 1 plus 1 whole square by 4. Okay. Now this is for p of 1 means n equal to 1. So we are here 1 cube means 1, and here we have to simplify. 1 means 1 square means 1, and 1 plus 1 2 whole square by 4. Here 1 2 whole square means 4. 4 by 4. 4 4 cancel is equal to 1. So 1 equal to 1. So hence the formula, this is 1 equal to 1. The formula p of 1 is true for 1 equal n equal to 1. Okay, now what, let us take n equal to k, and we have to prove like this only. Okay, in next step we have to take n equal to k. Okay, now p of k, that is 1 cube plus 2 cube plus so on plus k cube, okay, is equal to k square, k plus 1 whole square. In place of n I have written k, okay, denominator 4. As it is we have to write, but n place we have to take k. So now we have to show that, now what we have to show, n equal to k plus 1 in next step. Third step is, in second step we don't want to prove all the steps, okay, only we have to write in place of n we have to write k only. But in next step we have to show that n equal to k plus 1 is true. Okay, how it is possible, we have to take simple steps and we have to prove. Okay, now this one we have to show. Okay, simply in this one, s of k plus 1 is equal to what, k plus 1 whole square into k plus 1 plus 1 whole square by 4. This right side I am writing here, that is k plus 1 whole square into k plus 2 whole square by 4. Okay, in right side we have k plus 1 whole square, k plus 2 whole square by 4. Okay, since we know that s of k is equal to 1 cube plus 2 cube plus so on plus k cube, we know. Okay, so what we have to take now, we have s of k plus 1, okay, that is left side what, 1 cube plus 2 cube plus 3 cube plus so on plus k cube. Okay, okay children, do you understood like what we are doing here? K plus 1, in left side we have to write up to k plus 1 whole cube. This one what, this is s of k. Okay, this one as it is k plus 1 whole cube. Okay, now since we have s of k is what, s of k, k plus 1 whole cube. So we have s of k is equal to, s of k we have already here, that is what, k square, k plus 1 whole square by 4. So substitute in place of s of k, we have to substitute this value, k square, k plus 1 whole square by 4 in above, that is s of k plus 1 becomes what, this one, k square, k plus 1 whole square by 4 plus as it is k plus 1 whole cube. This can be written as s of k, k square. Okay, we can take k plus 1 whole square common. Okay, k plus 1 whole square common by 4 as it is I am writing here. Remaining one is k square, and here k plus 1 is remaining into 4 I am writing here, so that 4 is also taken as common. Now what, k plus 1 whole square into k square plus 4k plus 1. Simplify this one, 4k plus 4 by 4. K plus 1 whole square, this is what children, this is k plus 2 whole square formula. Since a plus b whole square formula, that is a square plus b square plus 2ab, like this we have in this form, no? So k plus 2 whole square, k square plus 4 plus 2 to 4k by 4. So k plus 1 whole square, k plus 2 whole square by 4. What we have obtained here, this is in the form of k plus 1 whole square, k plus 1 plus 2 whole square by 4. So we have proved that n equal to k plus 1 holds for this formula. Therefore, S of k plus 1 is proved. So the formula holds for n equal to k plus 1. Like this we have to solve, children. For any mathematical induction we have to take 3 steps, that is n equal to 1, p of 1 we have to solve, and next p of k, next p of k plus 1 we have to solve. Okay, by the principle of mathematical induction, go to the principle of mathematical induction. Remember what is given in the principle. So by using the principle only we have to solve the problems. Okay children, I think you understood this problem. If you understand one problem, you can do all problems. Similar problems are there in your textbook. Okay, solve by using this method. Okay, by the principle of mathematical induction, p of n is true for all n belongs to n. So that is the formula 1 cube plus 2 cube plus so on plus n cube is equal to n square into n plus 1 whole square by 4 is true for every n belongs to n, for all n belongs to n. Okay children, like this we have to solve. What I have done here, that I will repeat again children. Let us see, we have to take the statement given as p of n, be the statement, whole statement we have to take as p of n. Now in place of n we have to prove that for p of 1 also it is true. Okay, now putting n equal to 1 in left hand side and right hand side, we have to get equal values. Okay, now n cube means what? 1 cube. 1 cube means 1, so in left side 1, right side what we have to take as 1. 1 square, 1 plus 1 whole square. By simplifying also we get 1 here. So p of 1 is true for every n equal to 1. Now this is okay. Now let us take n equal to k. Okay, so whole problem is for n equal to 1 we have to do, and n equal to k we have to simply write and substitute in place of n we have to write k. Okay, this is easy, this step is easy. We have to write k cube and here k square, k plus 1 whole square by 4. Okay, don't simplify this, as it is we have to write in place of n equal to k. Now we have to show that n equal to k plus 1 is also true for this statement. Okay, now s of k plus 1 we have to first take this left side, what we have k plus 1 whole square, in place of n we have to write k plus 1. K plus 1 means k plus 2 whole square by 4. We have to show this. Okay, so let us take, we have s of k is equal to what? This one, k cube right side, and left side we have to take this one to prove this s of k plus 1. So let us take s of k plus 1 is equal to s of k plus k plus 1 whole cube. Okay, expanding we get this one. S of k plus 1 is k square, k plus 1 whole square by 4 plus k plus 1 whole cube. S of k we have right side this one value, substitute in this. Okay, we have to simplify this, we get the, we have hence we showed this k plus 1 is equal to this one, k plus 1 whole square, k plus 2 whole square by 4. So we obtained here. This is very easy problem children, I have explained you twice, so please watch complete video so that you can understand how to solve this mathematical induction problem children. Okay, very easy problem children, you can solve. If you have any doubts, please comment me in comment section so that you can clear your doubts on any topic children. So please see this question. Next question, show that 49 power n plus 16n minus 1 is divisible by 64 for all positive integers of n. Okay, very easy and important repeated question children. So I am going to solve how to solve this in exam. Okay, let us see this problem children. What we have to do in this problem. In this problem, some different type of problem is given here. Let us take what we have to take, p of n. Given statement is taken as p of n. Be the statement. Okay, mathematical statement we have to take as p of n. So 49 power n plus 16n minus 1 is divisible by 24. We have to show. Okay, we have to prove this one. Since we have the statement is true for n equal to 1, since we are writing here 49 n place, we have to write 1 plus 16 into 1 minus 1 is equal to how much? 49 plus 16 plus 1, 15 is equal to how much? This is 64. Okay, 64. So it is divisible by 64. Okay, divisible by 64. The given statement is true for n equal to 1. Okay, 64 is divisible by 64. So after substituting n equal to 1, this p of n is true for n equal to 1. Okay, this is over. First completed. We are substituted n equal to 1. Now what we have to assume? N equal to k. Assume that p of n is true for n equal to, this n is true for n equal to k. For every k greater than or equal to 1. K must be greater than or equal to 1 children. Okay, that is what? 49 power k. In place of n we have to write k. 16k minus 1 is divisible by 64. Okay, simply we have to write this statement that it is true. Then we have to take 49k plus 16k minus 1 is equal to 64t. For some t belongs to capital N. This is equation 1 we have to write. Okay. Now what we have to do? We have to show that p of n is true for, now we have to take n equal to k plus 1. Okay children. True for n equal to k plus 1. Okay. That is, we have to show that 49 power k plus 1 plus, that is what children? P of n is what? This one. 16 into k plus 1 minus 1 is divisible by 64. We have to show this one. Okay, this one we have to show. This one is divisible by 64, we have to prove. So from 1, now what? From 1 we have to show this one. From 1 we have, always we have to take same steps whatever the question is given children. In before problem also I have done same steps only. So see here, we have 49 power k plus 16k minus 1 equal to 64t. Okay, now 49k is equal to 64t minus, this comes to this side becomes minus and this one is plus 1. So what, now I am taking 49 here, multiplying 49 to both sides. Okay, 1 into 49. If we cancel, same step we will get. So multiplying 49 on both sides, what you will get? 49k plus 1. Bases are same, power should be added, means k plus 1. Here power is 1, no, k plus 1 we will get. And here as it is you have to write. That is 64 t minus 16k plus 1 into 49. Okay, this 49 t plus 1 k plus 1, and since we have 49 k plus 1, what we have? 16 into k plus 1 minus 1 is equal to 64 into t minus 16t plus 1 into 49. I am writing for this one, children. This one. For this one I am changing this above equation. If you have this one, 49k plus 1, we have this. Okay. To show that, substitute this 16 into k plus 1 minus 1. Okay. So I am substituted this 49k plus value in this. Okay, we obtain this equation. Simplify this 49k plus 1 plus 16 into k plus 1. Very important question, children. So I am solving step by step. So watch complete video so that you can easily understand the problem. 64t into 49. Every single term we have to multiply with 49. Okay, now plus 49 here, plus 16k plus 16 minus 1. Okay, now here 64t 49 into 16k, we have to multiply this one. 64 into 49t minus this one, what you will get? 784 minus 16, 768. Okay, k plus 49, 16 minus 1 means 15. 49 minus 15, 49 plus 15 means how much? 64. Okay, now take common 64. What will remaining here? 49t. Here 64 common here, minus 12k. 64 into 12, 768 plus 1. 64 ones are 64. So what we have obtained here? 49k plus 1 plus 16 into k plus 1 minus 1 is equal to what? 64 into 49t minus 12k plus 1. So what we have to prove here? 49 into k plus 1 plus 16 into k plus 1 minus 1 is divisible by 64. Yes, it is divisible by 64 for any positive integer, that is 49t minus 12k plus 1 is an integer. So 49t minus 12k plus 1 is an integer. So therefore 49k plus 1 plus 16 into this one, k plus 1 minus 1 is equal to 64 is divisible by 64. 64 by 64 means 1 is divisible by 64. Simply we obtain the value. We obtain that divisible by 64. So hence the statement P of n The given statement, what children? P of n is true for. Understood children? I think you understood by step I have shown here. So watch again. If you have any doubts, watch complete video. Go through my channel so that you can get videos. Okay, P of n is true for n equal to k plus 1. Hence we have shown here how to show that n equal to k plus 1 is true. Therefore P of n is true for, by using mathematical, we have to write in the last step by using mathematical induction principle. Mathematical induction principle. It is P of n is true for n belongs to n. That is 49 power n plus 16n minus 1 is divisible by 64 for all n belongs to n children. This is the method, this is the principle we are using to solve the mathematical induction problems. Okay children, I have shown you two different problems children, how to solve like these problems if you have given in exams. And this is divisible by, any problem is divisible by any number is given, we have to same steps we have to apply for this also. 3 steps for n equal to 1, n equal to k, and n equal to k plus 1. For n equal to k we have to use this and we have to show this k plus 1. Okay, simply very easy children. So watch complete video 1a maths 1a mathematical induction part 1, important problems, repeated problems children. Thank you for watching. Like, share and subscribe my channel for more updates. Daily I am coming live children for mathematics. Okay, join my channel, like and share, subscribe my channel with your friends and family friends. Thank you for watching. Thank you so much.